Okay, so now we have talked about clustering, we have talked about unsupervised learning, we have talked about one of the partitional based or center based approach, which is k-means clustering with k-means plus algorithm for random initialization. Okay, so I hope that you understood everything in unsupervised learning, and we have gone so much further into unsupervised learning. Now we are capable of learning hierarchical clustering, which is one of the most favorite and the best clustering techniques that include including partitional based, and then we have a hierarchical clustering. Okay, so this is what we are going to do. We are going to start with an introduction to hierarchical clustering to help you better understand what a hierarchical clustering is. Then I will go further into different just a quick recap onto partitional based. Okay, then I will show you the visual representation of hierarchical clustering and what is the dendrogram. Okay, and then we will move further into understanding the two types of hierarchical clustering, which is called agglomerative and divisive. Okay, so agglomerative clustering and divisive clustering, we will dive into agglomerative clustering and we will just take a look at the divisive. Okay, and then we will go further into understanding the agglomerative clustering algorithm, and then we will see then we will compute that algorithm manually, and then we will see the intercluster similarity between two points. Okay, but if all the words or technical terms are going above your mind, leave it. Means just ignore it, the words as of now. Let's start with hierarchical clustering, just introduction to hierarchical clustering. Okay, so what is hierarchical clustering? Hierarchical clustering is that you have a hierarchy of clusters. Okay, so for an example, what I'm going to do is I'm going to take 4 points. I'm going to take 4 points P1. Let's not take it here. Let's take P1 here, P1. Then I'm going to take P2. Then I'm going to take P3. Then I'm going to take P4. Okay, for an example, I've taken these 4 points and now we want to cluster it out. Okay, now we want to cluster it out. So how do we cluster it? So for clustering we have our favorite, means we can simply see, okay, this distance is small, these are more similar. We are going to do this. We are going to cluster it out like this. And we have this P3 and P4. How do we cluster? We cluster this P1 and P2 are here. So we cluster, we put another cluster. Okay, because this cluster P1 and P2 is P1 union P2. It is now a one cluster. Now in nearest the data point, nearest point between or the nearest, these are their own clusters. Initially these are their own clusters, so we are going to merge it. Okay, and so here we have a P1 and P2. Now this smallest distance is P4. Now we attach, means now we make one more cluster. Okay, now in this big cluster, where we have 3 points, what is the nearest data point now? The nearest data point is P3. Okay, so we'll make again one cluster, again one big cluster like this, until and unless we have one cluster at one cluster at a point. Okay, so here we are ended up with one cluster. Okay, so it is not making sense, I know, but we can just as a diagram I have made this. So let's see how we do it using a dendrogram. That will make more sense. Okay, so here we have a P1. Here we have a P2. Oh, oops, let me make a little bit more good. Oops, what happens? Okay, so here we have a P1. Let's assume that we have, this is the point P1, this is the point P2, this is the point P2, and this is the point P3, and this is the point P4. Okay, now these are the points. Now what we will do, here you can see, just assume that this is P1, P2, P3 and P4, and you can see this P1 and P2 are smallest, so we can make we can attach this, we can make a we can make like this, we can attach this P2 and P3. Okay, now these are one cluster. P2 and P3 are one cluster, which we usually call P2 union P3. Okay, now initially P1 is one cluster C1, P2 is one cluster C2, P3, C3, and P4, C4. Okay, so these are initial clusters. Now what we'll do, now this is the one cluster which is C2. Okay, so we found and attached it. Okay, now what we will do, now the nearest state data point is P4 over here. Okay, so what we will do, we'll again attach P4 into this. We'll again attach P4. Now we have P3 and P4 as a one cluster over here. Okay, now we can attach P1. Now we can attach P1. Now we can attach P1 like this. Now we can attach P1, and now we have our dendrogram, which is actually a hierarchy of clusters. Okay, so here we have a traditional dendrogram, which I think that you have all seen in your journey. So this is your dendrogram. What you have done, you have just, who are most similar, you attached it. Okay, who are most similar, you attached it. For an example, these are two similar, you attached it, and then this is now what you attach it like this. Okay, do not merge it. Okay, so you have to do like this. Now here we have, until and unless we have left with one cluster. Okay, so that's the basic hierarchical clustering, and I hope that you understood hierarchical clustering, the basic intuition. But if not, let's try to again understand a little bit more further into more sophisticated way. Okay, not sophisticated, just easy way. Okay, so for the example, I'm going to take a yellow color. So here you have a C1, here you have a C2, here you have a C3, here you have a C4. Okay, so this is your C4. Now you can, this C2 and C3 are your points. C2 and C3 are your points. Okay, so these are too much similar, so you will attach this like this. Now C4 here, so you will make one more. Now C3 and C4 will be attached like this, and C1 will be attached onto the up of C4. Now this is a traditional dendrogram. This is traditional dendrogram where you convert this cluster of numbers, C1, the clusters to a hierarchy of clusters. Okay, so for an intuition, what I'm trying to say you here, so I have one example. So for an intuition, what I'm trying to say you here, that we have a C1, C2, C3, C4. Now we're just attaching as a cluster, so C2 union C3, etc. Okay, so this is the basic intuition behind hierarchical clustering. So there are two types of hierarchical clustering. Some of the types are, we have some they call as agglomerative clustering, and then we have divisive clustering, and then we have divisive clustering. Okay, so we will deep dive into agglomerative clustering. I'll just give you an intuition behind divisive clustering. Okay, so what is agglomerative clustering? So the agglomerative clustering, agglomerative clustering. Okay, so before that, let's understand, let's understand the divisive clustering to help you better understand that. So it is up to down approach. Sorry, it's a down to up approach. Agglomerative is a down to up approach, and divisive is just opposite. Where divisive is just up to down approach. So what do I mean by this? So for an example, let's assume that we have 4 points. We have 5 points in the form of data A, B, C, D, and E. Okay, so here what you are going to do, you are going to divide this cluster of numbers, into a different AB. Let's assume that you are divided with AB. Now this is your CDE as a most similar. Okay, you divided this. Now what you will do, you will divide this A and B. Now you will divide this C and DE. Okay, now you will take the D and E. Okay, so this is the basic what you are doing, you are making the cluster of numbers into separate numbers. You're making the hierarchy of numbers. Okay, hierarchy of numbers and this is what you are doing. Okay, so you are just making a hierarchy of numbers. It's like ABCD is you're going to up to down approach, from up to down approach. But in the case of agglomerative, you are doing something different. You are here, you are going up to down. In agglomerative, you will take because in agglomerative you have cluster 1, C2, they are unique clusters, means only one cluster, so you do merge it. Okay, you do merge it. Okay, so it is agglomerative as up to down approach, sorry, down to approach, down to up. Okay, so that's the basic intuition behind agglomerative and divisive clustering. Okay, so we'll see in detail about agglomerative clustering and divisive clustering to help you better understand all of this agglomerative and divisive. But the basic intuition behind hierarchy of clustering is that you have some points, and what you do, you simply merge two cluster, because these P1, P2, P3 are P4 are 4 cluster initially. You merge two cluster, and then you have some kind of similarity matrix. Okay, so you have some kind of similarity matrix that we will see. According to that, you merge it, and then you make a dendrogram or hierarchy of clusters. Okay, so that's what agglomerative, and agglomerative is just down to approach, where you are converting the clusters into by merging different cluster until and unless you have one cluster left at the top, like this C1. Okay, as an example. And in divisive, you are actually going up to down approach, means dividing the cluster into a single group. Okay, like A, B, C, D, E. Okay, so that's the basic intuition behind this agglomerative and divisive clustering. Okay, so let's start with agglomerative clustering, deep dive into agglomerative clustering to help you better understand what an agglomerative clustering does, and we will see a lot more about this. Okay, we will not see the implementation as of now. We will see in another section where now after this, I think we have completed this theory part. All those stuffs means we now have a good knowledge of everything. Now what we will do, we will make lots of projects. Okay, so here's an algorithm. So first let me write an algorithm. First I will write an algorithm, and then I will make you understand with the help of good examples that I've already listed over here. Okay, so here first what we will do, first we compute the proximity matrix. We compute the proximity matrix that just tells you the similarity between 2 points. Second, we will see just as now how it looks like, and then you repeat these two process. Then you repeat these two process. Merge two clusters, and update the cluster, update the matrix, update the proximity matrix. Okay, so that's the basic, that you repeat in a for loop, and then you until you have one cluster, you have one large cluster left, means until you have covered all the cluster. Okay, until you have covered all the cluster. Okay, covered all the cluster, or we can say no clusters are left as a single cluster. Okay, but this is a more formal definition until you have a good cluster, like as an example that I've showed to you. Okay, so this is a basic algorithm to understand in agglomerative clustering. Now let's understand this in more detail. Okay, so initially what I've taught, what I've note here, and what I'm going to note here, like I'm going to write note, which is each cluster, or P1, P2, P3, each are its own cluster. Now we'll build a hierarchy of clusters. Okay, so let's build on proximity matrix, how it looks like. So the proximity matrix looks like this. Let's assume that you have P1, P2, P3, P4. Okay, I just assume as an example. Now what you do, you do this P1, P2, P3, P4. Okay, now you do this, means this is a proximity matrix. This is your proximity matrix like this. Okay, and these diagonals are 0. these diagonals are 0, the diagonals are 0, because the distance between the P1 and P2 will be obviously 0. The distance between P1 and P2 may be some 2.4, is P3, P4, like that. So we have written like that. The distance between P2 and P1 is maybe something like that. Diagonal, the distance between P2 and P2 is obviously 0. Okay, so this is what the basic proximity matrix looks like. So let's see that how we make a dendrogram. Okay, so here we have P1, P2, P3, P4. Now we will just assume that let's take an example that this is 4.6 to 4.2, 6.9, 7.2, 11, 12, 13, 14, 15, 16, 17, 18. Okay, it's a 0. Okay, so the distance between P4 is obviously 0. Okay, so the P2, we will find the smallest one. We will find the smallest similarity. Here you can see that this is the smallest similarity, P2, and I think it's a P2. And also I think that I've not drawn a good I will tell you. So here let's assume that you have this proximity matrix. Just don't take a look at this proximity matrix. Now what you will do, you will find the smallest similarity. So the smallest similarity over here is this 3. Here we have 3 and 6. Okay, so here we have 3 and 6 that we have done first, the smallest similarity. Okay, so that's what I'm going to do. So assume that this is P1 and P2 has the smallest. Now we have the next you can find over here is 4, means 6 and 4, maybe let's see 6 and 4, which is here. Okay, so we can go over here also, 3 and 4, we can see this 3 and 4 also. Okay, so we can take this 3 and 4 like this. It's okay, so just assume the next smallest is P3 and the next smallest is P4. Okay, so now we have constructed. Now let's assume C2, P1, P2, P1, then we have again maybe some P3 and P4. Now first you do this, then you do this, then you make this like this. Okay, so now you have the hierarchy of clusters. Okay, so that's the basic definition, that's the basic algorithm for proximity matrix. Okay, and this is what you do, and you update the proximity matrix. So how you update? Now you merge the cluster. Now what you will do, P1 union P2. Okay, P1 union P2. This one will be, let's assume P1 and P2 are attached, then P1 union P2. This will be the cluster. Okay, now let's assume that the 2.7 and these are similar, means this 2.7 and maybe some like that, so we can combine the cluster like that. I think this is not an actual example, this is a bad example. Okay, but here you will be seeing one more comprehensive example. Okay, so how do we measure the similarity? How do we measure the similarity of the inter-cluster similarity? We can measure the distance between two points or clusters, these P1 and P2, using maybe Euclidean distance, Manhattan distance. We have different distance measures. So how do we measure the similarity between two clusters or intercluster? An intercluster is nothing much this is your one cluster and this is another cluster. So what's the distance, what the similarity between to merge it? Okay, so that's the intercluster that we have already talked about in terminology sessions. So let's see. So we have let's assume that you have this. Let's assume that you have this cluster where we have X, this. Let's do another cluster, this. So how do we measure the similarity? So for measuring the similarity, we have, I'm going to talk about three methods. Min, the next method max, the next method is group average. So let's start with min. So what do I do in min? So let's assume that you have this so you have this data point like this. You have this cluster. Now the second cluster is like this. Okay, so what you do in minimum? what you do in minimum, you take out the minimum first. Just write from let me write it mathematically to make it more sense. Oops, what I've done. Okay, so what you have to do, so let me write it mathematically for minimum. So minimum is just the similarity between C1 and C2, which is nothing but equals to minimum of Pi is member of C1, Pi to be the member of C1. Let's assume this is C1, so Pi may be this point, and Pj, the another cluster, should be the member of C2. Now what you will do, you will take out the similarity, the similarity of Pi and Pj. Okay, these two. Okay, these two distance. Okay, now you take out the distance, that you take out the distance. I'm writing here distance, and you take out the minimum points who have, means here you the distance between these 2 points is minimum as compared to this point. Okay, so we will just what we will do, we will simply merge it. Okay, so this is what the basic minimum approach does. It just takes out the similarity between C1 and C2 by the taking out the minimum of all the I and j's, by taking out the distance between all the taking out the minimum distance of all I and j's with the member of C1 and C2. Okay, so that's the minimum. So let's see the basic thing over here to understand it a little bit further away. And this example is taken from CS6 530 by Cluster Analysis class lecture notes. This example. Okay, so here is your proximity matrix. Here is your proximity matrix where you have 1 as a P1, 2 as a P2, like that. Okay, now you have here you have a proximity matrix. Here you have a proximity matrix. Now here the distance between 1 and 1 is 0, the distance between 1 and 2 is 0.24, the distance between 1 and 3 is 0.222, the distance between 1 and 4 is 0.37, the distance between 1 and 5 is like this, and in the same way diagonal are 0. Okay, so you can see here the smallest similarity between, or smallest distance between 2 points I and j. Here we have, let's assume this is I and this is j, so smallest distance is 0.11, and we have 3 and 6. Okay, so we merge 3 and 6 as a first cluster. Okay, now the next smallest similarity or the smallest distance is this one. Let me choose, yeah, this one, 0.14. Okay, so 5 and 2. Okay, so this is your next smallest. So now what you will do, you will merge it at a second cluster. Now what you will do, you will find that this cluster you this P5 union 2 and 3 union 6 finds to be has the smallest distance, so you merge the cluster 3. Next is you have 1 and 4. Now what you do, you take out the you can see first you take out here we have 4, in which this union and this 4 has the smallest distance, so you merge it and then you make a big cluster again, and then you are done. Okay, so it might make sense, it might not make sense further, but I will walk you through, go through this example, make the dendrogram by yourself or nested clusters by yourself. Okay, that will make more sense. The next type of this is max. What do I mean with max? Max is simply taking out the similarity between C1 and C2, which tells us the maximum, which we want the maximum distance between Pi and Pj, and Pi be the member of C1 and Pj be the member of C2. So that's the basic definition. That's the basic of this. Instead of we are taking the max. So what do I mean with max? So here we have an intuitive or comprehensive example. So here you can see that we have again the same proximity matrix. Now you can see and then the smallest distance is 3, 6. Okay, you merge it. Now, how you will merge this 4? How will merge? Why don't we merge with 5? Okay, so the distance between this 5 and 2 is a maximum, is very large. So obviously this one obviously will be minimum. So you merge it. That makes sense. That makes sense obviously. Okay, so this is why you take minimum distance, but for merging you take the maximum. You take the maximum to merge, and here you have taken the maximum, and that's how all it works. And here we have a maximum, here we have a minimum. So you take out a maximum, and then you compare, and then you take out a minimum, and this is obviously will be minimum, and then you can see this is the maximum here, and this is the minimum from here. So you merge it. Okay, so this is the basic, and you can see the dendrogram over here how we made. Okay, the next type of intercluster similarity measure. The next type of intercluster similarity measure is group average. What do I mean by group average? Group average. So I'm just going to give you the intuitive, as a simple equation, which is Pi with a member of C1 and Pj with a member of C2, Pi with a member of C1 and Pj with a member of C2. You take out the distance between Pi and Pj divided by the norm, because it's the frequency, divided by the norm of C1 with whatever the number of points times the times the norm of C2. Okay, so this is what you have to do. I think it may be plus, yeah, it may be plus, yeah. Okay, so you take out the norm of what is the number of points, frequency. Okay, so that's what you are going to do. So you can see over here that we have this dendrogram, we have this following, and then what you do, you group it. For an example, you can see the same thing has been done, but I'm going to take another example to help you understand this much better. So you have this first, and then you have this second cluster. Okay, now you have some points. You have some points in here, you have some points in here, and some points in here. Okay, you take each pair like this. You take each pair. Okay, now you average it out. Okay, and then you take out the distance, you average it, and then here you go. Okay, so for an example, here you take out the minimum distance is 3 and 6, and then you have this 4. Then again you merge it using the in max what we were doing, but here we are merging 1 also. The reason being the average between will be making sense if you sense it mathematically. Okay, and 5 and 2 are closest. Okay, so this is what you are doing in group min, and let's see some of the just this minimum disadvantage. The minimum disadvantage is it is sensitive to outliers. It is sensitive to outliers, and rather than max is will be less prone to outliers. Okay, so that's the basic disadvantage that I've told to you, and you can see more onto the CS6 for 530 cluster analysis lecture notes to understand it much better. Okay, so this is what we are doing, and if you have not understood, it is a little bit advanced, but it should make sense little bit what we do in this. We make hierarchy of clusters like this. Okay, so now we have talked a lot about hierarchical clustering, and I hope that you really understood everything you need to know about hierarchical clustering. Now what I will do, I will just name some now what I will do, I will name a time complexity, and a space complexity. Now I'll name one time complexity and a space complexity for agglomerative clustering, just to make sure everyone is on the same pace. So the space complexity is order of n square. Okay, because you have a proximity matrix too, and time complexity will be order, or maybe sometimes it's order of nq. Okay, but sometimes it goes to order of n square log of n. Okay, so this is your space and time complexity to understand it much better, and you can see the limitations, pros, cons of these onto the Wikipedia pages. They are really well explained there. Okay, so we are done with hierarchical clustering, and I really hope that you understood everything. Now we are done with unsupervised learning. Now we will do a lot of projects, and then we will end up this course. And I highly recommend you to do lots of projects also. Okay, and then after learning this machine learning, you can go to New Era. Again, I'm going to just now navigate here the URL https you can /youtube.com/new era. Okay, so you can find and just take a look at a newly launched deep learning series. Okay, from there you can learn advanced machine learning or deep learning. Okay, so that's it for this session. So that's it for whole this subsection. I'll be catching up your next section.